After dimensionality reduction that you can use, so there are many different, so you can use PCA, you can use TSNE, UMAP, if you use the right parameters. You can also use ICA or diffusion maps, so that you have up to 5 options how you can do. Now you want to find the lines connecting in your data. So one of the ways to do is minimum spanning tree. And you'll see many methods that use exactly this method for finding what is the trajectories in your data. So given a set of points in your data set, the idea of minimum spanning tree is how can we connect all those points using just as few lines as possible. So for example, here you have the lines connecting all the data sets. And if I sum all those lines, like here, I can connect all the points in the data set, and this sum is minimized. So having more transitional cells, like in the middle here, will help to have this definition of the graph better. So here I cannot stress enough that you need to have the transition cells in your data set. So, and the weights here between the cells can be correlations, can be distance on PCA or ICA space. For example, here is usually ICA. It can be anything, or distance on a UMAP or distance on a TSNE. And by definition, minimum spanning tree has no cycles, so cell cycle cannot be modeled using this method, for example. So you really need to think about which method you want to use and why, and I'll come to that later in the presentation as well. And this basically is the definition of the first trajectory paper using in monocle. So you have independent component 1 and 2 on ICA, and then you find the minimum spanning tree that connects all cells in your data. And then you can also find this bifurcation of the different cell types there.